This video looks at reflections of matrices. Now, in the x-axis, if you look at the diagram that I have, we have the point P, which is 3, -1, and its image is 3, 3. So what you'll notice is that the x-coordinate stays the same and the y-coordinate swaps signs. Okay, so if the y was positive, it would become negative and vice versa. So when we think about that, the image of xy equals x negative y. So to put that in a matrix, we have 1, 0, 0, -1 because our y coordinate is changing sign. Okay, our x coordinate is staying the same. So in terms of a matrix equation, the image of xy is equal to 1, 0, 0, -1 times by xy. Now let's look at reflection in the y-axis. So with the y-axis, our x-coordinate is the thing that changes now, and our y-coordinate stays the same. So our x-coordinate swaps sign, and our y-coordinate remains unchanged. Makes sense, okay, because our y stays the same. It's just flipping across the y-axis. So thinking about that, our image of x and y, the image of x is negative x, and the image of y is the same as y. So in terms of a matrix, we have -1, 0, 0, 1. So our x has swapped signs and our y has remained unchanged. Now let's think about in the line y equals x. So if you look at the example I've got here, our x coordinates and our y coordinates swap. Okay, so when x was 4 for our pre-image, it becomes, and y was 1, our image, our x is now 1 and our y is 4. So our x and y coordinates swap. So the image of x is y and the image of y is x. Now, you also have to take into account whether it's in the line y equals x or the line y equals -x. Realizing that our y equals -x is on at the opposite diagonal. Okay, so that would be y equals -x. So if it's y equals x, we simply swap our coordinates. So you can see that where the 0 for x and the 1 for y, and then the 1 for x and the 0 for y. And if you think about it, think about your across the row down the column. So when you look at it in terms of the matrix form here, you're going 0 times x, so the x is gone, 1 times y, which is y. So your x is becoming y. Then 1 times x is x, 0 times y is gone, so your y is becoming x. Okay, so think about it that way. If you're in the line y equals -x, then you just need to put in the negative value. And again, think about that matrix multiplication so it sinks in and you understand why this is happening. Because these formulas are not on your formula sheet. Sorry, these matrices are not on your formula sheet. So you need to know where they're coming from. So let's look at an example. Determine the image of point -2, 3 after reflection in the x-axis. So our matrix is in the line y equals 0 because it's in the x-axis. So that means if we think about in the x-axis, our x-coordinate remains unchanged, but our y-coordinate flips sign. Okay, so our image xy is going to equal 1, 0, 0, negative 1 times xy, and our xy is negative 2, 3. So that's 1 times by negative 2 plus 0 times by 3, 0 times by negative 2 plus negative 1 times 3, which becomes negative 2, negative 3. And that makes sense because when you look at your original point, if it's a reflection in the x-axis, that means x is the same, y changes sign. So that means you'd have negative 2, negative 3, which is what we found. So therefore, image point is negative 2, negative 3. Next, after is transformed by the matrix negative 1, 0, 0, 1. So our image is going to equal negative 1, 0, 0, 1 times xy, which is negative 1, 0, 0, 1 times negative 2, 3. Negative 1 times negative 2 plus 0 times by 3, that's 2. 0 times by negative 2 plus 3 times 1 is 3. Okay, so therefore image point is 2, 3. And that's a reflection in the y-axis. Because negative 2, 3 went to 2, 3. So our x's have flipped, but our y's have stayed the same. Use a matrix method to determine the image of triangle ABC defined by the points A, B, and C as given when reflected in the line y equals x, and verify your solution. So our matrix, remember they swap places. So it's 0, 1, 1, 0 because x and y swap. So our image of point 1, our image of point 2, and our image of point 3 is going to be that matrix times by our coordinates. So A is 2, 0, B is 5, 1, and C is 6, 6. I'm just going to do that on my calculator. You can do it by hand if you want. We get 0, 1, 6, 2, 5, 6. So therefore, the image points are A02, image of B is 1, 5, and image of C is 6, 6. Now to verify that, A is 2, 0, B is 5, 1, and C is 6, 6. And then the image of A is 0, 2. Image of B is 1, 5. And image of C is 6, 6. Just move that B coordinate. And if we think about the reflection in the line y equals x, you can see that that's correct. Use a matrix method to determine the image of the line y equals 2x minus 1 when reflected in the y-axis. Verify solution. So in the y-axis means our x's are swapping, y's are staying the same. So our matrix equation is that. Now to get x, y on its own, we have to pre-multiply. So we get the -1 oops, just a refresher on solving. So that leaves our x, y on the right-hand side. Now, the inverse, I'm just going to do down the bottom here. -1 times by 1 is -1 minus 0. Swap. So we got 1, -1, and they stay because they're zeros. So that's -1, 1, 0, 0, -1, which becomes -1, 0, 0, 1. So come back to here. Cross the row down the column. So we have negative image of x plus 0 lots of y, 0 lots of the image of x plus 1 lots of the image of y equals xy. So therefore, x equals negative image of x and y equals the image of y. So if y equals 2x minus 1, plug that in. Image of y equals 2 lots of negative x minus 1. Image of y equals -2 image of x minus 1, and that's our new equation. Okay, now we covered that in the last video. Go back if you don't recall, but we're just replacing the x and we're replacing the y. Okay, we covered that in translations. So y equals 2x minus 1. Y-intercept is -1. 2 times 1 is 2. 2 minus 1 is there. So we've got that line. Join the dots. So that's y equals 2x minus 1. Now for our image, that's going to be exactly the same, but with a negative gradient. So pick the 2 points and join the dots. Label. And you can see that that is a reflection in the y-axis. So verified. Now there is another option for solving in this one and finding what we need, and it's from this step here, and it saves us having to find the inverse. So if from this step you write out your equation, so I'm going to write that step out again. So if we do the multiplication on the right-hand side, we get negative 1 times x is negative x plus 0y, and 0x plus 1y. So that means that our image of x equals negative x, and our image of y equals y. Okay, getting x on its own, x would be the negative x, negative the image of x. So go to our equation, y equals 2x minus 1, and substitute these in. So this is very similar to the method we used in our translations. And you end up with the same answer. Okay, so that is a lot easier than having to try and find the inverse matrix and going that way. It does mean that you don't get that answer straight out. Now let's look at another example. Determine the equation of the image of y equals x squared after a reflection and the line y equals negative x, and verify your solution. Pause the video and have a go yourself. Okay, it's in the line y equals negative x, so our x and y swap and change signs. So write out our matrix equation. So that means cross the row down the column. We have negative y, negative x, which makes sense because they're swapping and changing signs. So our image of x equals negative y. Our image of y equals negative x. So that means y equals negative the image of x, and x equals negative the image of y. Y equals x squared. So negative x image equals negative y image or squared. So that is the same as the image of y or squared. So I can go to the image of x equals negative the image of y all squared by taking negative over, or I can get y on its own and say the image of y is plus or minus a square root of negative the image of x. And then sketch. So y equals x squared. And the reason for going to this version of the equation is you can see it's a sideways parabola that's reflected in the y-axis, which makes it a little bit easier to draw. And our reflection was in the y equals negative x, which is that line there. So you can see that that's verified.